Kia ora, ko Jack Beagley. I'm a year into my PhD at the University of Otago. I'm researching the oceanographic processes that affect the carbon burial that Gary was just talking about. It's a part of an MBIE-funded project, and we're in partnership with Ngāi Tahu ki Murihiku, and in particular Oraka Aparima as kaitiaki for Fieldland. So you're all experts on fjord carbon burial now, so I can skip that slide. But I will still show you a couple of photos I took. I always find it so impressive when I'm in the fjords. You see these landslide scars just everywhere around the fjord in kind of varying stages of regeneration. You know, you see bare rock in some places, and then as the decades kind of come through, you get the mosses and then the bigger trees and so on. So the kind of dynamicism of these processes is so evident as you're kind of going through the fjords. And, you know, when you're just cruising around, you see all of that organic litter in the kind of at the surface as well. So I find it fascinating. I love getting in there. I'll talk a little bit more about kind of, I suppose, as a fjord oceanography 101. So Gary talked a little bit about this, but I'll talk a little bit more. So at the top, we've got this low salinity layer that's driven by the vast amounts of fresh water that enter the fjord. In all the fjords, most of the fjords, we've got big rivers that enter them. We've also got rainfall that falls directly on the fjords. And in Patea Doubtful Sound, we've also got this 500 cubic meter per second unnatural river, which is the Manapori Tail Race, which is constantly inputting into the fjord. And that drives this fresh, low salinity layer, that's constantly going out to the coast. As that goes out, it mixes in with salt water, and you have this intermediate water that comes in underneath it. So you've got this estuarine circulation, this kind of conveyor belt going in at the bottom and going out at the top. One thing that makes fjords really unique compared to other estuarine systems is they've got this entrance sill here. So this is the actual bathymetric profile for Patea Doubtful Sound. At the fjord entrance, it's about 130 meters deep, but it goes all the way down to 430 meters in Malaspina Reach. And we've also got this kind of sub-basin here, which is Deep Cove. But this sill is really interesting in that it separates this kind of deep water below sill depth with water at the same depths off of the coast. So it actually can be quite stagnant, and it's not constantly in exchange like the intermediate water and the low salinity layer. What this means is that with all the organic matter entering the deep water, you know, collecting as sediment at the bottom of the fjord, it can become depleted in oxygen, and that's what can make it quite favorable for preservation of organic carbon, like Gary was talking about. They're not necessarily stagnant forever, though. You can kind of think about it as like a cup of tea that's been gradually stirred around. So we get this kind of, we call it vertical diffusion, where the properties of that deep water evolve to become like the properties of the intermediate water above it. And that makes it lighter and lighter over time. You know, fjords are naturally very stratified environments. We've got the lightest, freshest water on top, then it gets saltier and denser generally as you get to the bottom. But over time, it's getting lighter. And what that means is if we get denser water off of the coast here, it can actually come in and replace that water in the deep basins. And that's not just bringing denser water with it, that's actually bringing new oxygen as well. So depending on the frequency and strength of these processes, it can highly influence how effective the sites are as carbon preservation sites. Just if you like analogies, that you can kind of think of these deep basins as kind of mountain areas, and the dense water at the bottom is kind of like an inversion layer, which kind of, in the case of a mountain valley, is driven by temperature, but we have salinity playing a part in the ocean as well. So Gary's already talked a bit about the different controls on organic carbon burial, and my project is focusing on the oceanographic conditions, which, as I mentioned, drive the oxygen where the sediment's lying. So there are a few things we can use to investigate these changing properties. One of the things I use the most in my research is an instrument called a CTD, which measures the conductivity, temperature, and dissolved oxygen in the water. What we do is we tie a really, really long rope onto this and drop it all the way down to the bottom of the fjord and then bring it up again. and we can do this, well, the more often the better, but what we're doing is we're comparing how the water properties change over different time periods, and that kind of gives us an idea of the processes that are going on in the fjords. We're really lucky in the case of Patea Doubtful Sound. We've got legacy data going back to 2012 that was collected by postgraduate students in a field school class. So I thought you might like to see what the data looks like, and I can kind of talk you through what I look at when I'm investigating it. So I've got 4 graphs here showing different properties of the water: salinity, temperature, density, and oxygen. This is all in Deep Cove, so not too far from where the tail race comes out. The dashed lines are the water properties in May, and then the solid lines are the same properties in November. So we can see actually quite clearly those 3 different layers of water. At the top, you can see the salinity just goes horizontal. What we're seeing there is the actual plume from the tail race. That's basically completely fresh water at the top of Deep Cove. And then we see the salinity in May is gradually increasing until we get to about 55 meters. Then we get another step change and little variation. So that step is occurring at the sill depth of Deep Cove. So we're actually looking at the relatively stagnant water beneath that. Now, this was data collected last year, of course, but when I saw it, I was like really amazed. This is the first time we sampled the site at this time, and it was really interesting because we saw the highest oxygen we had ever seen at the bottom of Deep Cove, and we can see the density has increased significantly going from May to November, and these are really clear indicators of those deep water renewal events that I was talking about earlier. Looking at the longer term time series, this is Malaspina Reach now. Sorry, again, this is a little bit to take in. I've got, again, water properties at 3 different depths. I chose the colors really poorly, I do apologize. But we've got the light blue being water properties at 130 meters, which is the sill depth of Malaspina Reach, and then the darker blue being 270, and then while we don't have it every year, that purple is near the bottom of the water column. A few different things to take away from this. In a few cases, the water properties change in slightly conflicting ways. So in the middle of the water column at about 270 meters, sometimes we see the density increase, which would suggest that a renewal event has occurred, but then the dissolved oxygen has decreased, which is the opposite of what we might expect with a renewal event. And there are actually some parallels with some of the research we heard about whales earlier on, where you see one in 2002 and then not again until 2022 or whatever it was. We don't know what they're doing in those time periods, and we have a similar issue in the fjords where my guess is that it's actually not following the perfectly straight line that this graph might suggest. So luckily, more recently, Doc, Richard Kinsey, and the crew on the Southern Winds have been helping fill in some of those gaps, which is why we've got much closer space points later on. Another thing we see, looking at the bottom, this is temperature. So this darker blue here, you can see it's gradually increasing as we go throughout the years, and that kind of reflects a generally warming trend. And in particular, in kind of early 2023 is where we see the highest values of temperature at the bottom of the fjord. And this is likely related to the really extensive marine heat wave that we saw off the coast. It's actually quite like almost unexpected that we see the changes penetrate to that depth. As I was saying, they're really stratified environments, and normally that heat wave water would be a lot lighter. We would kind of expect it to just sit on top. So it's really interesting that it's actually mixing enough to see that signal at depth. Yeah, so I'm only a year in, so I'm still working on my final conclusions. But one of the key things that we found is that these annual samples actually, I don't believe, have been high enough resolution to really resolve the dynamics going on in the system. So we're really fortunate to have partners like Doc who are helping to really increase that temporal resolution. Although some other stuff I've been looking at suggests that these renewals might be occurring on an annual to interannual timescale, although that's going to depend on what site you're looking at. We found generally warming trends in the deep water, And going back to that kind of May to November, May to August cast, we think we've got some really quite good evidence of a renewal that's occurred, not just in Doubtful Sound, but we actually saw that signal in Dusky and Preservation as well. So it seems like it's been a Fiordland-wide event. Moving forwards, where I'm hoping to deploy some moorings in Pattaya Doubtful Sound, hopefully 3 spread around the fjord. That should both constrain better in time some of these events, but also let us really refine some of the quantities that would describe the processes. We've got another member in the research project who's working on a computer model of the fjord. So we kind of set it up with initial conditions, temperature and salinity at this location, that location, and you can use coastal water properties to drive that model. So hopefully we can replicate this renewal event that we saw last year with the model and really nail down what the triggers were of that event. Once we've got a model that we're verified and happy with, we can use that to investigate all kinds of things. What happens if we turn the tail race off? If we put lots more fresh water into the system, how does temperature affect it? And we might even be able to look into carbon transport too, because that's the other role that oceanography plays with the whole system. Yeah. Anyway, that's a brief overview of my research to date, but thank you very much for listening.